Everyone, welcome back to Pine Hollow Auto Diagnostics. Today we're working on a 2004 Toyota Tacoma with 240,000 miles and a rusty frame, but it's here for an airbag light, flashing airbag light. Now, of course, we start with the scanner, and here's the code: B0138, short in the PT, that's pretensioner, squib left circuit, battery positive. Now, I did a little bit of homework and printed out a diagram, and indeed this code is for the pretensioner left hand side. So this is the airbag module. We got front airbag sensor left hand, front airbag sensor right hand. Those are the kind of crash impact sensors. Then we have our squib. That's the front passenger airbag assembly. This guy here. And our clock spring goes to the steering wheel airbag right here. And then it has two seatbelt pretensioners. And we're getting a code for this guy. Yeah, that's better. So anyways, let's do some voltage checks. So using our scope right over here, we figured out which connector is which. So the one on the left is connector A. That's C, because it has three wires going to it. There's a yellow, black, and a green with black stripe. Right there, three wires. And this guy on the right side only has two, yellow and yellow black. That's how we can distinguish between our C connector with three wires and our A connector with just two wires. So we're worried about pretensioner left hand, connector C, three wires. That's this guy here with the red tape. So if one is broken, one is not, it's perfect. We have a known good and a known bad. So we're just going to take our probe and go on these wires. So the yellow black is PR plus, yellow is PR minus. Right pretensioner, it's known good. So let's just check those real quick. Yellow and black right here. Interesting. So that is our pattern. It goes from 0 to 4 volts. This is a 1 second screen. PR plus. Now PR minus, the neighboring pin. Pretty much the same pattern. So what is it trying to do? It's trying to just, I guess, measure the continuity through those wires. So that's a known good. Let's go to the other side, the left hand pretensioner. Do the same checks. Yellow and black, completely different. So now it's going from 6 volts down to 2. It's kind of getting pulled down, almost like an inverse, not quite. And on the second wire, on the yellow, same thing. Quite interesting. So there's definitely a difference between these two pretensioner circuits. What we can do next is power down the system, turn it off, unplug the two pretensioners, and just do a resistance check on those guys. I think that's the next easiest step. So we got both pretensioners unplugged from the module. Let's see what codes this thing set. No codes present. That's messed up. Now we got to reboot the scanner since it got all confused. Alright, now we got some more codes. Open in pretensioner squib right circuit, open in pretensioner squib left circuit. Awesome. Let's clear these out and make sure only the correct two codes return. Poor connection airbag sensor connector. Okay, obviously, because these connectors are kind of special. They have these shorting bars on there, and I think some of the pins on the module obviously have to be connected so it knows, hey, it's plugged in, and then it does the circuit check. But in this case, the circuit fails and the connector is not plugged in, so it's pretty smart. So those three codes, it's not saying short to battery positive in the squib right circuit anymore. Does that mean we have a bad pretensioner? That is the question of the day. So we can plug them back in, make sure our problem still exists, and then see if the connector at the pretensioner is easy to access. So with the connectors plugged in, now we can do a resistance check. The system is off. That's very important. You don't want any voltages to interfere with your measurement. 2.8 ohms on the known good right hand side pretensioner. Okay. Now let's go to the driver's side. Just the wire to wire. Make sure you make good contact in there. We have 3.2 instead of 2.8. Seriously? It's gonna fuss about 0.5 of an ohm. Let's make sure our connections are consistent. There we go. 3.2 instead of 2.8. 3.1. I mean, that, you would think that's close enough. When you disconnect the connector, it drops down to 0.8 because the shorting bar did its thing, shorted out the connector. Now it's 4.7. Why? Did that make a difference? 0.6. Plug back in. 4.6, 4.5, 5.0. Doing a little wiggle test on the harness here. Alright, let's just turn the system on again. Turn the voltmeter off. Let's read the codes. Current codes. No codes present, and the airbag light is off. Okay.
That's gonna cost extra.
History codes. Yeah, I'm gonna charge extra for the repairs too. Alright, let's clear the codes out again. Clear codes, yes. Continue. So let's see, key off. We don't have anything connected anymore. That's it, the system is as is. Everything's plugged in. Key on. And airbag light goes out. That was the bulb check. Codes only. Current codes. No codes present. History codes. No codes present. Wow. Let's go back to our scope and see if the actual pattern changed. So we're recording. Let me set the scope up real quick. Alright. Well, that's pretty close to what we saw before. Now, voltages might be the same. The airbag module is sending out kind of a test pulse, but the current through that pretensioner probably has a very fine tolerance, and if it's out of spec even by a little bit, you know, maybe there's some oxidation on that connector on the pin. And we've seen this before on the video, remember, with the Chevy truck, the Silverado. It had I think a B0044, also a code for one of the airbag actuators, and we messed with the connector at the module, plugged it back in, and the truck is still fixed as far as I know. My neighbor drives every day. He would have, you know, told me if the airbag light was back on, and that was like 4 years ago. So that's a known good signal. So they actually use a different pulse for the driver and the passenger side. We can even plug in a second channel here to compare the driver and passenger on one screen. Why not? We have plenty of scope capability. So I'm just going to go into here, turn on channel 2. So channel 2 is the passenger side. Channel 1 is driver side. I don't know. I guess that's known good. So if anyone's doing scope captures on the airbag module, 0 to 4 on the passenger side and about 6 to 2 on the driver's side. Again, airbag light is off, and final check for the codes. No codes present, and no codes present. So we can spray some deoxit spray on there to keep those pins from oxidizing. Recheck for codes, but I think this truck is fixed for now, except for the frame. And the dealership is actually giving the owner a frame under the warranty replacement, so that's pretty cool. This truck will go on forever as long as the frame stays in one piece. What's that? You want at least 500,000 miles out of this thing, right, Jeremy?
That's what I'm calling for.
All right.
It's 15-year-old truck now.
Yeah, it's basically just needed oil changes, and that's about it. And a couple belts.
TLC, some petting.
Yeah, a couple clutch kits.
Well,
yeah. Wear and tear, just normal wear and tear. I think it still might be on the original timing belt, which is some kind of record. But with that, thanks a lot for watching. That's it. Not much of a, I don't know, diagnostics and repair. I guess it was all kind of a two for one deal here. See you guys next time. Bye bye.